Hey, AP Chemisters, this is Mrs. Blankwalle bringing you part 2 of Blankwalle 4.3. We are still working on limiting reactants, theoretical yield, and percent yield. So I left you with problem number 9, where we actually calculated the theoretical yield. It is how much you should make if you're not in lab. And we're going to still do the same thing in problem number 10. We'll do a percent yield problem a little bit later on, okay? So why don't you go ahead and start problem number 10 from scratch for you, all right? So you have to figure out what the actual equation is. You need to figure out your balanced equation. You need to figure out your moles of each reactant, find out the limiting reactant, and find out how many grams are left in the excess. So, like I have asked you in a prior video, that when I say pause this and do it, I mean it. I want you to work this out yourself, struggle with it if you do, and then come back and learn from mistakes if you have any, okay? So make sure you pause this and do it. So this is what I did. I balanced it over here. I got 4 and 4. I have 32 grams of S8, which is a form of sulfur. And notice the molar mass is the 32.07 times 8. Okay, that's where that 256.56 came from. And when I divide it, I get 0.125 moles of S8. And then I found out how many moles of chlorine I have. Notice it's almost 1 mole. And then I can put those two numbers in over here. All right, and if you look closely, 0.125 divided by 1 times 4 is 0.5. When I was looking at this myself, I actually looked at this. What's 1 divided by 4 is 0.25. That would have been too big if I used chlorine as my limiting reactant, which meant my sulfur was my limiting reactant. So I put the 1.25 or 0.125, 0.5, 0.5. So I subtracted out, I have excess chlorine, and I made 0.500 grams of the disulfur dichloride. So my limiting reactant is the sulfur. How many grams are left of the excess? Well, here I want my 0.500 moles of my chlorine, which is this number right here. That's my excess. Then I multiply by the molar mass, and I got 35.5 grams. Okay. Well, what about problem number 11? Okay, let's kind of scroll this one down here. Come on. Okay, well, all right, so we obtained titanium metal from its oxide according to the unbalanced equation below. Notice I have 28.6 kilograms of carbon and 88.2 kilograms of titanium dioxide, or titanium 4 oxide, you probably should say. You are actually producing 42.8 kilograms. That's your actual amount, okay? So now find your limiting reactant, your theoretical yield, how much titanium should you make, and then your percent yield. So please pause this and see how you do. So here I go. Here is my actual amount. Notice how I convert everything to grams so that they would cancel out with the 12.01 grams. And then I got 3 sig figs. This many moles of carbon. Put it right here. For the titanium 4 oxide, I start with 88,200 grams, but its molar mass is 79.9. And I end up with, there are 3 sig figs here, so if you really want to make this perfect, you'd put little, whoops, don't do that. You'd put little lines over it. Go away. Thank you. Come here. There we go. So you put little lines over like this. Oh, let's use blue. Put a little line here, and then we'd put little lines over here and here, all right? And notice that the titanium 4 oxide is my limiting reactant, so I use it to determine the amount of product, all right? And I even put little lines. Why am I doing that? Because there's 3 sig figs for those, okay? And then I have, my after, I subtract, add. So now what? Find the limiting reactant. I did that. It's titanium 4 oxide. My theoretical yield, well, I think I want it in grams, right, of titanium. Why titanium? Why not carbon monoxide? Because they tell me this right here. Because you have 42.8 kilograms of titanium is produced. So I want to figure out how much should I make. So I have my 3 sig figs here. So it's 1100 moles, and here's my molar mass of titanium. So here's my theoretical yield. Again, I have my 3 sig figs of 52,700 grams I should make. So how do I find my percent yield? Do you remember I have that formula on a prior page? Here it is. Whoops. Here is the formula. So percent yield is actual over theoretical times 100. So how much did I actually make? We'll look at the problem again. Here it is. I actually made 42,800 grams of titanium. I theoretically, that's what my BCA table tells me, is 52,700 grams times 100%. I get 81.2% yield. Okay, so let's see what the next page is. All right, so how many liters of carbon dioxide will be or should be produced when 4.8 grams of oxygen react with carbon monoxide? Now, right now, do you already know which ones you're limiting? Oxygen. Why? Because you don't know anything about carbon monoxide. So what do you assume? You assume that you have excess carbon monoxide. So this problem's a little bit easier. When you perform the experiment, you only collect 5.23 liters. What's your percent yield? So why don't you go ahead and once again pause this, do it on your own, and then come back when you're done. Okay, this hopefully was a little bit easier because I have 4.8 grams of oxygen, so with 0.15 moles. Notice I have excess over here and I have 0 to start with. Obviously, this is my limiting reactant, so 0.15 divided by 1 times 2 is 0.3. Same thing here. So I have plenty of carbon monoxide. I run out of oxygen and I make 0.30 moles of carbon dioxide. But I don't want moles. Look at what the value right here is, 5.23 what? Liters. They're not asking for grams. We need to find the liter. So how many liters of carbon monoxide do I have? Well, I have 0.30 moles. And remember that number I told you in a prior video? It's 22.4 liters. I'm assuming it's at STP because they don't tell me otherwise. So I end up with a theoretical yield of 6.7 liters. But now what they asked me for my percent yield, which is again actual over theoretical. I actually made 5.23 liters. I theoretically should produce 6.7 liters times 100%, and I get 78% yield. Wait a minute, what about my sig figs? Well, look at here. I have only 2 sig figs here, which I carried through with my moles, which I carried through with my moles, which I carried through with my liters. So what's the rule when you divide? You have 3 sig figs, 2 sig figs. My answer should have 2 sig figs. Okay. Well, that's it for section 4.3. Hopefully you remembered this material and, keep practicing if you need to. All right, so don't wait to be great. We'll see you later. Bye-bye.